Okay, this red graph is the graph of this cubic function. This section right here, let me get a different color, confirms that when x is 2, y is 19, just in case there was a typo here. So 219 is definitely on the curve. If you find the derivative of that function, that's a formula for slopes of tangent lines for any point on the curve. So the derivative, using the power rule, is 6x squared minus 2x. The derivative of the 7 is 0, of course. So if we find f prime of 2, we're actually finding the slope of the tangent line at the point on the graph where x equals 2. And that's 20. So the slope of this black line is actually 20. And if we want to write the equation of that line, we use point slope. We know the slope, m. We know a point that it passes through, 2, 19. So y minus y sub 1. Y sub 1 is the y coordinate of the point of tangency, equals the slope times the quantity x minus x sub 1. And if you want to, that's point slope right there. If you want to put it in slope intercept, just isolate y. So y equals 20x minus 21. If I share my screen for a second so that you can look at this graph. Here's the graph. I created another tangent line over here, a movable point. And as I move that point, there's the tangent line at that movable point. There's where it is coinciding with the given point. Okay, and so you might want to take a look at this graph and see some of the stuff that's being done on Desmos. The name of this point is Q. I'll label it Q. And there's the movable point. And if you want to, you can say what's f prime of q dot x. That's the slope of the tangent line right now. And then, of course, that changes as we move the point. See, it's getting pretty steep there. It's getting to a point where maybe the slope is 0. And then it starts going back up in slope, steeper and steeper. There it is, about the 20. Okay, there you go. Hope that helped. If you have any questions, post a comment.